All right, finding the domain and range of the relation. So remember, when we find the domain is going to be x values. So if I wanted to find the domain, because it's just a list here, we're just going to list them. So domain, we just list. The range, now it's just going to be the y values, and so we list them. Now technically, you don't have to put them in order. You don't need to repeat them if it's repeated, but you don't have to put them in order. It's just nice to put them in order. It makes it easier for the reader. Now, next one, it says x is an odd integer and y is an even integer. Now, there's a few ways to go about this. If you wanted to list it as roster method, just create a pattern. So if x is an odd integer, I can do ... -5, -3, -1, 1, 3, 5, ... So I created a pattern, and those are all the odd integers. And then the even integers for the range, same idea, but now I just list the even numbers. So -, so ... -6, -4, -2, 0, 2, 4, 6, ... For this next one, same idea, because it says ... that means we know that it goes on forever. So for my domain, what are my x values? -3, -2, -1, 0, 1, 2. Okay, so it's just counting. So we just establish a pattern, and then you can do ... And then my range looks like it's 0, 1, 4, 9. So it looks like there's some pattern here going on. So 0, 1, 4, 9. Now what's the pattern? +3, +1, +3, +5. Okay, so +7. And once you establish a pattern, so it's going up by an odd number. You can also look at it as 1 squared, 2 squared, 3 squared, 4 squared. The next one, just reading this, it says my x has to be -2. So -2. Now my y, my range, I can write that as the interval here. So -3 to 4. Now the domain and range on the graphs here. So if I wanted to find the domain of this, the domain, we're just going to list the values. Same with the range. I'm going to list the values, -1, 0, 1, 2, 3, 4. For this, right, the domain, if I project it, so that becomes -infinity to -1 union from 1 to infinity. And the range, if I project, everything's going to get shaded, so that's -infinity to +infinity. And then here, if you project, all of that's going to be shaded to there, so that's going to be -infinity to 0. And then project, union, open circle from 1 to infinity. Whoops. So that's the domain. I'm going to clean this up so it's easier to visualize. And now for the range, okay, so project, so shade, and then shade. So the range would be from negative infinity to 1, union, and then 2. I know it might be thinking, oh, it's an open circle. So yes, if this one gets moved over, it's an open circle, but all of these behind it are closed. So it just fills it in. 8, does the temperature outside depend on the time of day, or does the time of day depend on the temperature? This may seem like a silly question, but sketch a graph that represents this relationship. You first need to decide which axis will represent the quantity. So in this instance, it's going to be, at least the way to think about it, is the temperature doesn't tell you what time it is, but based on what time it is, we generally know what the temperature is, right? If it's 4 o'clock in the afternoon, it's towards the hottest time of the day. If it's in the morning, it's going to be some of the coldest parts of the day, right? So the time of day, so time is going to be here. That's the x-axis. And then the temperature, that's going to be the y-axis. And so when you graph the equation such as y equals 3x minus 5, which variable x or y depends on the other, which is not dependent. So the independent variable is going to be x, and the reason why it's independent is because the time of day in this instance, or the x in that equation, it just goes, it just exists, right? Now the time of day will then tell you, which is the dependent variable, the y, it'll tell you what the temperature is going to be, right? So it's like 5 o'clock in the morning. If I pick 5 o'clock in the morning, bam, I know what the temperature is going to be. If I pick 3 o'clock in the afternoon, bam, I know what temperature it's going to be. Now sketch the graph. So graph the y-intercept, up 3 over 1. And then this could be something along the lines of, this could be, 0 o'clock, right, or midnight, and then 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m. The next one, it says, given these two functions, complete parts a through f. So calculate f of 3 means you plug in 3 into your function. Now if it says solve f of x equals negative 5, that means you set it equal to negative 5. So you're going to say negative 5 equals negative 2/3 x plus 3, and then you're going to solve for x.